Welcome to Intro to GPG and Web of Trust. We can get to it. So like you said, my name's Doug. I'm not going to mention my last name either. I think I'll butcher it too. So I'm a software developer at Rackspace, and I work on cloud security products. And so what that means is I get to work with some really talented security folks. And I get to learn some cool stuff. They also make me really paranoid. And so that's sort of where I got interested in GPG and sort of what all they can do for us. So given that this is a crypto track talk, I figured we'd introduce the usual players. And so this is Alice and Bob. And so Alice wants to be able to talk to Bob over an insecure channel, right? And some of the things that they're going to be worried about is I don't want eavesdroppers. So if I'm Alice, I don't want anybody to listen to sort of the things that I want to talk to Bob about. So I want to make sure that when I send a message to Bob, only Bob can read it. I also want to make sure that if I was Bob receiving this message, I want to make sure that the message is really coming from Alice, and it's not some other person pretending to be Alice. And I also want to be pretty sure that the message hasn't been changed in transit, right? Like maybe Alice tried to say something, somebody intercepted it in the middle of the way, changed up the message, and then gave it to me, right? So these are sort of the things that I'm concerned about when trying to talk to somebody else. And so what Bob and Alice can do is use GPG, because GPG provides a lot of really cool features that can sort of help us secure these insecure communication channels. And so one of the things that GPG can provide is confidentiality, right? And so this speaks to that concern about preventing third parties from reading your communications. And so what GPG can guarantee is that only the people who have access to the right keys are able to read the messages, right? And so pretty much like anything in encryption, the security is going to come down to how secure you can keep your keys. And so if you keep your keys pretty secure, it'll provide confidentiality for you. It'll also provide integrity. And so with GPG, we can sort of have that assurance that a message has not been tampered with in transit. And then it'll also provide non-repudiation, which I couldn't find a good picture for that, unfortunately. But it basically means that once somebody's written a message, they can't deny having written it. And so you can sort of relate this to like signing a contract in the real world. If you sign a contract with somebody, later on you can't go back and say, well, no, that wasn't really me. This has got your signature on it. So GPG sort of provides us that concept of having a signature as well that you can't repudiate. Also interesting is, saying, okay, well, if sort of the contrary is true too, that you can't produce a message and claim that I've signed it or that I've sent it without my signature. So there's that. And so once we think about all those three things together, then we can sort of have this assurance that a message is authentic, right? I know that nobody else has read it except for the people that are intended to read it. I can make sure that it hasn't been tampered with, and I can be sure that the person claiming to send it really is who they claim to be, right? And I can do that with GPG because it all uses encryption under the hood, right? And so I'm gonna just do a quick little crypto 101 so we're all on the same playing field here. And so the first thing I want to talk about as far as crypto primitives is going to be hashing. And so hashing, I'm a developer, right? I like to think of this as just some function. I don't care about the implementation. But I basically give it some input. It gives me some output. The input we're going to call the plain text or the message. And the output is going to be the digest. And so what's interesting about hashing is that given the same input, it'll always produce that same digest, right? And then the digest is always going to be the same size. So whether you give me a huge email, huge file, or just a little bit of text, the size of the digest is always going to be the same. And one of the interesting features of cryptographically secure hashes is that even just a little bit of a change in the message will cause a completely different digest, right? And so for example here, we're using SHA-256 as the encryption, as the hashing algorithm here. And if I was to just hash this message, attack on Pearl Harbor, December 7, you can see the hash that this would produce. If I change just one character on that, you can see that the hash is completely different, right? So this is one of the tools we're going to use in GPG to sort of guarantee that a message hasn't been tampered with, right? We'll be able to compute the hash of a message and then If the hash is different than what we expect, we'll know that it's been tampered with. And if it's the same, we'll know it's good. Another form of encryption used in GPG is symmetric encryption. And the idea here is that basically there's two functions, right? The encryption and the decryption function. And they both work with the same key, and that's what makes it a symmetric encryption thing, is that it's the very same key used for encryption, used for decryption. You know, give it a plain text in the key, it gives you the encrypted ciphertext. The key and the encrypted ciphertext then with decryption gives you back the original message. So this is useful when you have to encrypt something for a lot of people. You sort of give all the people that same key, and then everybody can decrypt this thing. Sort of another encryption scheme that GPG uses is asymmetric encryption. And so the interesting part here about asymmetric encryption is that you have a key pair. So these are two different keys that are sort of related to each other, right? They have this special relationship. And because of that, they're able to do some pretty neat stuff. Like whatever you encrypt with one key, you can only decrypt with the other. It doesn't matter which key you use. You know, if you encrypt it with one, only the other one can decrypt it. And sort of the inverse of that is true, right? Like if I'm able to decrypt something with one key, then I know for sure the other key was used to encrypt it. That's basically the idea behind public key encryption, right? Except that here we're taking those two pieces of this key and assigning a role to each one. So one of them is going to be our public key, and we're going to publish this, just give it out to people, attach it to your email, put it on business cards, whatever. Public key can go to everybody. And then I'm going to keep that other half of the key, that corresponding key pair, I'm going to keep that private. And so then what I can do is that anybody who's got a public key can encrypt things that only I can decrypt because I'm the only one who's got the private key. Now, I mentioned earlier, and then I'll mention it again a couple times throughout the presentation, like it's real important that you keep those keys secure, right? Especially, anybody who gets a hold of my private key can effectively pretend to be me. So important that we keep these safe. Also interesting is that anything that I encrypt with my private key, anybody else can decrypt who's got access to my public key, right? And so that might not seem, interesting at first. It's like, well, why would I want to encrypt something that anybody can decrypt? But the implication here is that the only person that could have encrypted it is me because I'm the only one who's got the private key. Everybody with me so far? If you got questions, by the way, just raise your hand or yell at me. And so once we start combining these things, we can make some really interesting stuff, right? And so if we think about hashing and then asymmetric encryption, and we use those together, we can arrive at this concept of digital signatures. So basically, the way a digital signature works, this is how we would make one, how I would sign a document. So I take the document and I calculate a hash. Remember, the hash is just going to be that small unique number that's going to be different for every message. And then I take my private key, which only I have. And when I take that digest, that hash I calculated, I'm going to encrypt it with my private key. And then that effectively becomes my digital signature. And then I can attach that to my message I want to send out and send it out to everyone. And on the other side, whenever somebody receives that, what they can do is they can take that. This is an important step, right? They can take the message and calculate a hash themselves of the message they receive. Now remember, we talked about hashing. If you hash the same message, you'll end up at the same hash or at the same digest. So first, I take that message I received, calculate my own hash of what I received. Then I take that digital signature and I use the public key of the person that sent it to me to decrypt it. Now remember, because I'm using the public key, the only thing that could have been used to encrypt that is the private key, the corresponding private key. And then what that'll give me is the digest that the person who wrote the message arrived at. And what I can do then is take that message that I decrypted and the message or the digest I calculated myself, and I compare the two. And if the two are the same, then the implication of that is that the message has not been changed, right? Not only has it not been changed, but the person who wrote it is also in possession of the private key that matches that public key. Everybody with me so far? Awesome. And so the important part here, obviously, is the key, sort of the operations. We don't need to get into the details so that, like the GPG tool, will be able to manage that for us. But the key management is a pretty important part of GPG, one of the sort of the complaints about it is that it makes you manage too many keys, right? So if we go back to think about Alice and Bob, well, if I'm Alice, I'm going to have, obviously my private key that I'm keeping secret, and I've got my public key too. And then I want to send a message to Bob, and I want to send this as an encrypted message, right? And so for this to work, I'm going to need Bob's public key, right? I'm going to need their public key so that I can encrypt something so that only they can decrypt it because only they have the matching private key. But if I also want to talk to Carlos, in addition to Bob, I'm going to need Carlos's public key too. As a matter of fact, I'm going to need the public key for every single person that I want to communicate with via GPG. And so you can sort of think of GPG as the key management aspect of it as like a big contact list or a Rolodex or something like that, where you're constantly keeping these public keys from people that you're communicating with. And there's a couple of ways that you can get those. They can send them to you directly. There's a couple of file servers, public file servers, where people upload their public keys. And so if we talk about GPG keys in sort of the way that we're going to think about them, so they're going to be stored locally in some database. And then GPG, I'm mostly going to talk about the command line tool because I'm a developer and I like the command line. But there is some nice user interfaces for this if you're not comfortable with the command line. So one of the options I have here is to list all the keys. And this is going to show me basically every one of my contacts for which I've acquired the public key. It's also going to keep track of my private key or many private keys. Some people choose to have more than one. Maybe you have a project or something like that you want to dedicate a key to. So those are all going to be listed there. Also, your private keys are going to be protected by passphrase. Now, it's important that you make this really hard to guess, because in the event that somebody gets a hold of your private key, the file, now remember the private key is still going to be a file on disk. Somebody gets a hold of that, the only thing that's going to prevent them from using it is going to be this passphrase, right? Every time you use your key, you have to punch in this passphrase. Keys also have a unique fingerprint. It's a really long number. And this is how you can sort of coordinate with people to make sure that you're talking about the same key. This fingerprint is going to be unique for everybody who's using GPG, right? And there's also what a lot of people call a key ID, which is the last 8 digits of the fingerprint. Now, this is sort of a shorthand kind of way of doing stuff locally. It can be dangerous, though, because there's some attack that you can actually fake this key ID. And so when you're talking about exchanging or verifying keys, you want to make sure that you use that full fingerprint. The GPG key itself is actually going to consist of a whole lot of cryptography keys. We don't really need to dive down into what the keys actually are and stuff like that unless you want to. But basically, when I talk about your GPG key, it's actually a collection of a bunch of different keys. There's a key pair that's used for signing. There's a separate key pair that's used for encryption. You can actually, out of the box, you'll get 2 keys, signing and encryption, but you can also add other sub keys if maybe you want a different key for encryption depending on the email address that you want to use or whatever. And one last thing that your GPG is going to have attached to it is a user ID or UID. And it's basically going to be a legal name that you want to use. This will be, usually your given name. So my key will have my legal name on there. Comment, which is just whatever you can think of to help people identify your key or identify you as you. And then some email address. And this is how it's going to sort of tie into your email system and stuff like that. Is you'll be able to identify these keys by the email address that's attached to them. We can actually, if we list out the fingerprint here, you see I'm referring to a key ID for my own key. And this is the fingerprint right here. And so if I was to want to communicate with one of you guys, I would give you my entire key fingerprint. And then it would be your responsibility to, when you download the key, verify that those fingerprints match. You can also see here, this is showing me my public key. If we were looking at a private key here, it would say SEC. These are all options of what the different actual cryptography keys underneath are. You can see here I've got my master key up here, 2 sub keys down here, and I'll get into sort of what this means here in a little bit. And actually have like 4 user IDs on my key. I've got 4 different email addresses that I use. And so I use the same key for every single one. A lot of people like to use separate keys for different email addresses. It's really up to you on your comfort level with reusing the key. So the first thing you're going to want to do, well, first you're going to want to install GPG. And so most Linux distributions have that out of the box. For Mac, there's a project called GPG Tools that you can download and install, and it'll come with the command line client as well as the email plugin. For Linux, for email, you can use Thunderbird with a plugin called Enigmail. These are all plug into the command line system and the database and all that. That's all shared. And so usually, like when people get excited about GPG and want to go try it, this is what happened to me. Like I'll go, yeah, I'm gonna go make my key, and then it starts asking you questions, and then you don't really know what's going on. And so the first thing that it asks you is like, what kind of key do you want? Now this relates to the actual crypto keys underneath. There's a whole lot of different options. I'm not gonna get into the details. I'm just gonna recommend that everybody do RSA and RSA. In newer versions of GPG, this is the default. If you've got a little bit older build, you gotta make sure that you're choosing the option to have RSA and RSA. This is going to be for the master key and the sub key. But DSA, you don't really want to, the key space is too small nowadays to be really recommended. So if you want a key that's going to last you a good 5-10 years, my recommendation is pick RSA and RSA. Next thing it's going to ask you is for a key length. Basically, the idea here is the more bits you have, the harder it would be for somebody to guess the key. Now, also, there's the trade-off of efficiency there. So if you pick like the absolute highest bit key possible, then that's going to make it difficult for people who have to verify. Like they'll have to do more work. They have an older computer, it might take a while. It's a trade-off. My recommendation would be to do 4096. As you can see, the default is 2048. Which is currently considered secure, but I want my key to last, a good 5-10 years. So bump that up, 4096, that would be my recommendation. It'll ask you then about expiration. It would be a good idea to set your key to expire. If you don't really know whether you want it to expire or not, you can set this to 0 or set it to not expire. You can always change this later, so don't think about it too much. Like, do I really want it to expire? Is it gonna be, is it gonna last a while? It doesn't matter, you can change it later, and you can always make a new key later on. After that, it's going to ask you for generating this user ID. It's going to ask you for your real name. Now, I recommend you actually use your real name because it'll help people that want to communicate with you that can't get a hold of you right away. Ask for your email address, and then a comment, just a helpful comment to help people find you. And then it'll, summarize the user ID in that format that I talked about earlier. Once you say OK, then it's going to ask you for your passphrase. And this is going to be real important that, you think of a good passphrase. Also, the safest place for this is in your head. Like, don't write it down on a piece of paper next to the thumb drive that has your key. That'd be bad. And like I mentioned earlier, if somebody was able to compromise that key database that includes your private key, the only thing that's going to prevent them from using it is going to be this passphrase. And so at the end of that, we can print out the fingerprint, and this is what we would have. It's considerably smaller than mine because this is a brand new one. As you can see here, we're looking at a public key. 4096 here is going to be the bit length of the key. So here we can sort of verify that it did make the correct size. The R there is going to be for RSA. So whenever you check on your key, just make sure that R is there for RSA. Fingerprint. This fingerprint is going to correspond to your master key, and it's actually going to be the same no matter, like whether you add subkeys or remove them or expire them over time. This fingerprint's never going to change. So this is the thing that you can get, tattooed on your arm to give to people and stuff like that. Then, as we can see here, I've also got a sub key. Like I mentioned earlier, the master key is used for signing. Subkey is for encryption. Subkey is also 4096. Also RSA. And this is the fingerprint of the subkey. We don't really use this much for anything. that I'm aware of anyway. And then one more thing, one sort of more security feature you can do is create a revocation certificate and put this in a nice place. A revocation certificate basically tells people like this key is no longer valid. And the reason you might want to generate this up front and then just keep it in a safe place is that in the event that your laptop that was the only laptop that had your key or something like that blows up, then your revocation certificate, if you have one already created and stored, will serve to tell people like, hey, this key is no good anymore. I've actually got a buddy who had 2 really nice keys that he'd gotten signed by a bunch of people and stuff like that, and then he wiped his hard drive because he thought he had backed them up and he had not. So his keys are gone forever, and they still look like valid keys because he never made a revocation certificate for those. So this is important to have, not necessary, just a little extra security measure in the event that you lose your key. Yes? So would you be able to recreate the key with your passphrase? No. No. The passphrase is really there just to unlock the key. Yeah. So then also, so now that we have a key, we're going to want to share it. One way to share it is to export the key. And here, export is only going to export the public key, right? This is not going to share my secret key with anybody. There is an export secret keys command if you want to back it up. Back up the secret one, that is. Armor here is just telling it I want to use ASCII armor, so it's just going to look like plain text on the file. And then I give it my key ID that I want to back up. And I'm just piping all that out to a file. Now this is a file that I can start giving people, right? Like this is my public key, here you go. Whenever you're trying to email me, like use this public key to do encryption and signing and all that good stuff. Another way to share your key is to upload it to a key server. Now there's a few of these and they all, I think, sync with each other and stuff like that. The one that I've seen people, or the one that the people that got me into GPG were using was this MIT server. Ubuntu's got one too that they use. I don't know if I mentioned, a lot of distributions use this to verify their packages when you're downloading packages. And so stuff like Fedora and Ubuntu will have their own key servers for hosting and stuff. Now the key servers are interesting because they're write-only. And so once you upload your key to the server, it's there forever. And so my buddy that lost the keys, his keys are on a key server and they're going to stay there forever, unfortunately for him. Yes? No, because he didn't make a revocation certificate. So when you have a revocation certificate, you want to keep that in a safe place, right? So like on a thumb drive, in a safe or something like that. And when you're ready to revoke the key, then you would push that revocation certificate up to the server. And then the server would correlate the two and then show that key as being revoked. Yes. And so once we've got our key, once we've shared it, we can actually start doing some pretty neat stuff. We can start signing our email. This is something that I started doing once I started the GPG because I don't really need anybody else to talk to sign my own email. And the idea behind this is that people that are then receiving my email, so I talk on a lot of developer mailing lists and stuff like that, if they want to, they can take the time to calculate this hash on my message and then calculate the signature and verify that it's fine. If you've got a nice GUI like GPG tools for Mac, which is this tiny picture up here you probably can't see, it'll have like little status bars, right? So if you receive something with the signature, it'll have a nice green check mark there that tells you that the signature was good. If it's got a signature that you don't have the key for, it'll have a little yellow question mark that, you know, hey, this might be good, but maybe not. And then if for some reason you get a message with a signature that doesn't match, it'll highlight that in red and tell you, hey, don't trust this email. The signature on this is invalid. GPG tools, the way it does that is it attaches a file when you send your email. So people receiving your email, they'll just see this little attachment, maybe try to double click it and it won't make sense to them. In Thunder, or what am I trying to say? Thunderbird, the email client with Enigmail. It actually does all the signing in plain text, sort of like this. And so I think Enigmail does actually give you a little status bars as well. but you can then also take this plain text and sort of manually calculate these things yourself. You can also start signing your files, and this is something that we do with OpenStack releases, right? Like I'm making a tarball of this software package, and I want to assure you that the tarball that you're downloading is in fact the one that the developers made. And the way we do that is by signing the actual file, right? And so there's a few different options for signing. The one that I like to use is this detached signature. And then you give it the name of the file, and so what that'll do is it'll read that entire file as input and then give it the signature for the file as a separate file, right? And then you can put both of those up on your website to download. People would download both the file and the signature, and then on their side, run this verify. And then given that they have your public key, then it'll tell them that, you know, the signature was good. And then you can go ahead with the installation of the software because, you know, the software hasn't been tampered with. You could do this too, so if you wanted to send, you know, send pictures to somebody. I don't know what you'd want to sign a picture. You probably want to encrypt it. You can also start to encrypt files for yourself. This is something you could do without needing somebody else's key. And the way you could do that is just say encrypt, give it the file name, and then -R is the parameter for the recipient. Normally here you'd put the key ID of the person you're emailing, or maybe the email address of the person you're sending this to. But if you email it to yourself, right, like that's effectively encrypting it for yourself. Later on, you can use your private key to decrypt it. And so this is something I do for like Google two-factor codes, you know, the backup codes or whatever. Save them on a plain text file, encrypt it with my GPG key, and then I can throw that encrypted file on Dropbox or whatever. I don't care. Nobody that doesn't have, the only person that can decrypt it, presumably, is me, because only I have the private key. And then decryption, pretty straightforward, just --decrypt. GPG will actually read everything it needs from that GPG file, and then it'll output that to the plain text file. You can also start encrypting email. GPG tools, when you start writing an email and it notices that you have the private or the public key for the person that's receiving it, it'll automatically encrypt it for you. And so this terrible picture up here is what it would look like in Gmail, right? Like this is an encrypted email I received in Gmail. It's just a bunch of garbage. If I look at it on my email client that has the correct keys to decrypt it, I can actually see it there, the actual message. Over here, the little status tells me that it's signed correctly by that email address I was expecting, and that it's also been encrypted. Everybody with me so far? Looking pretty cool? Awesome. So the last thing I wanted to talk about is the web of trust, right? So I've talked a lot about, you know, exchanging keys, and it's pretty easy to do if you can talk to the person or if you know the person, but it's very difficult to do if you're trying to email somebody you've never met before and you don't know for a fact like which key is theirs. So I mentioned those key servers, the public key servers are write only, but they're open to anybody, right? So if I wanted to send a message to, like, I don't know, George Bush or whatever, if I go check on that key server, there's going to be like 65, 70 different keys with that name, right? So how do I know which is the correct file? And so GPG's answer to this is called the web of trust. And sort of their definition of trust here is really simple. Is when you trust, or in GPG, trust is when you sign somebody else's public key. Oh man, that slide is wrong. That's the public key you sign. And it basically means like, hey, I've verified this person claims is who they claim to be, right? And this is why it's important to use your legal name on your user ID for your key. Because usually the way this works is you can ask somebody, hey, would you sign my key? Sure, let me see your key. Okay, it says here you're Doug so-and-so. Let me see some government ID or some other kind of proof that sort of ties you, the person, to that name that's on the key. And if that's sufficient for me, then I can attach a signature to their public key and then push that up to the key server. And so, oh yeah, how to get your key signed. You can get it with friends, coworkers, these things called key signing parties. Usually that's a bunch of GPG people that get together for the sole purpose of verifying each other's IDs and signing each other's keys. It's a really good way to get a whole bunch of signatures. So the way you sign the key, obviously I already mentioned, first you check their ID, make sure that their name matches whatever their official ID they're presenting to you. If you want to be real thorough, you should email that email address that's listed on the key to make sure that that's the email address that they can receive email from. And then you just say, GPG sign key, give it that key ID, and then GPG will go through the process of creating those signatures. And so here's an example of listing the signatures in a key, right? This is the public key for a buddy of mine, Igor, that's running around here somewhere. And you can see here he's got a public key, 4096 RSA, and that's his name is Igor. And he's got, I guess his comment is his IRC handle or something like that, and he's got his email address there. And then I see a bunch of signatures. Now the signatures are going to be, each SIG entry here. And I can see here that he's got a bunch of signatures from people that I don't know. So those don't really matter to me. Interesting one here is a signature that I myself put on there. And so one cool thing about signing somebody else's key is that because a signature is only valid if the thing hasn't been tampered with, then you can, if you check your own signature at a later date, you know that that key has not been tampered with. Also interesting is he's got a signature by Tyler. Now I've met Tyler at one of the GPG key signing parties, and I know he's a pretty trustworthy guy, and I know he's real thorough when he checks for IDs. And so if I didn't personally know Igor, well, I probably wouldn't have signed his thing. But if I saw that Tyler had signed it, then I'm more inclined to believe that this key does indeed belong to him. Because I know Tyler wouldn't just sign anybody's key, and because he signed Igor's key, then I'm pretty sure that this is indeed Igor's key. So verify those signatures, right? So I have all the public keys for all these people. And so when I run the check signatures, it's only going to show me the signatures for the public keys I collected. The little hash bang here is what tells you that that's a valid signature. One of the features that you can activate with this is managing trust, right? And so you can sort of set the threshold of how much you want to trust people. And so if I met somebody at a key signing party, then they're at least interested, so maybe I trust them marginally, like I can give those people a 3. And the way you do that is, you say edit key, this person's public key, and then I'll give you a little GPG prompt, and there you say trust. And then these are your options, so you just assign them a number. And so what the software can do is automatically sort of add up these things of if it's a new key that I've never seen before, but it's at least got 3 signatures from people that I trust, then I'm more inclined to trust that key that I hadn't seen before. Does that all make sense? Lots of nodding, awesome. And then sort of the last thing I wanted to talk on is this is sort of like an iterative process. Like this is something you got to continuously do is refresh your keys. And so you want to get into the habit of, every couple of weeks or maybe every month or so, refresh your keys from the key server. And so what this will do is it'll go out to the key servers and pull down any new signatures that may have been added. It's also important you do this because that's how you would pull down revocation certificates that may tell you that, something's been revoked and stuff like that. And that's all I have. I'll distract you guys with a relevant XKCD so you don't ask me questions. No, I'm just kidding. You can ask questions. Yes?
So after you've signed someone's key, what do you do to ensure that you push that back up to the key server?
So a lot of people recommend that you ask the person how they want to receive your signature. Some people don't like having their keys pushed to public key servers, so they might ask you to just email the file after you've signed it. So I would ask the person whose key you're signing what their preferred method is. But you could always push it up yourself. It's just some people consider that rude.
Yeah, so if they're cool with that, you push it up and everyone, when they refresh their keys,
will get your signature. Yep, that's correct. Yes, I'm back.
Any thoughts on GPG and Yosemite, the issues that they...
GPG and Yosemite? Yeah, so it's a real bummer that GPG tools does not work with Yosemite. I haven't actually kept up with a mailing list to see sort of what they're doing. I believe that it's only the email client that broke for me anyway. Like the command line client still worked.
I've had issues with command line too, so I didn't know if I was. I mean, I see some other people have, but on and off. So I didn't know if you.
Yeah, so I haven't had problems with the command line tool, but the mail plugin did break for me. Right. So I'm really hoping that they're working on it. Fingers crossed. But Thunderbird does work on Yosemite. So if you need a backup plan right now, check out Thunderbird with an email.
Okay, thanks.
Mm-hmm. Do you have any plugins for Gmail so that we can evaluate?
Not currently. So doing crypto in the browser is kind of dangerous, and I couldn't explain to you why, because my security expert friends are the ones that tell me that. But I did hear a news bit that both Google and Yahoo are working on some sort of encryption scheme for their email, and they're both basing it on GPG, right? Also, if the only thing you have is a Gmail account, you can just set up like an IMAP client and just install GPG on your client, but it won't plug into Gmail directly.
So instead of signing for validation, can't we use the email address for validating the person?
Not necessarily, because it's really easy to fake email, right? And so you could, maybe you could, without GPG, you couldn't ensure the email was valid to then start doing GPG. Does that make sense? Like a chicken and egg problem, right? Back in the back?
Yeah, so GPGs, you're explaining, how it's really good at things like non-repudiation and privacy, but it's not good, or not really that, it's not good for anonymity. So we still have this really hard problem of, we don't know how to send anonymous email. I was wondering, if you've looked into the mix-in networks at all to help, if you use GPG to send anonymous.
I've never had to send anonymous email via GPG, so no, not familiar with that. Yeah, I don't know how you'd go about that, but yeah, that's definitely a problem with GPG, right? Like, it's not all rainbows and unicorns. So another criticism that I hear is it's really hard to use, it's tough to manage keys, which, I mean, the fact that I have to sit here for 40 minutes to explain how to get into it, sort of speaks to that. Also, Web of Trust, like you mentioned, a lot of people are concerned that it leaks information, right? And so if I go to a key signing party and get a bunch of signatures, people will know that I was at a key signing party with all these people. And so there's definitely some criticisms to it too. Cool. Any more questions? No? Awesome. Well, thank you guys. I'll be around if you have any questions or need that, please submit.